All right, so this is a resubmission of the Fresnel equation um, screencast and our standard. And what I've done is I've created some situations and put them in Mathematica. And as you can see, or as you probably can see here, I'm having some issues because something's not happening right, and I don't know if it's syntax or if it's just I'm putting in impossible conditions. If you could help me kind of think through that, that'd be great. So anyway, so let's say we have an angle of 45 degrees. So incident onto the interface is 45 degrees. The angle transmitted of, let's take that away. I'm actually going to be calculating for that, so we don't know yet. We will find that as long as our calculations work. The incident S field is 1 watt. I've got incident S is incident S, and then the incident P field is 2 watts. So I'm trying to make the argument that that there is a that there's more that there's more P light than S light, which I don't think should be a problem. And we're looking for reflected E, P, and I. So I got my conditions here. Theta I is 45 degrees. Theta R is equals theta I. That's angle equals angle out. And then we have PIS, PIP, and then I am the intensity of P. Now we know that that intensity equals power times area. So, and I am saying, I see a slight problem here. Because if that's the case, that has to be 1. Okay. I went back through that because if I'm claiming that power and intensity is the same, the area has to be 1. Okay, Fresnel and Snell. This is where this doesn't like me. Obviously, n sine theta I equals n sine theta t, n t sine theta t. And then I've got my second equation, which is the for Ts, and I've got the for Tp. And I'm using the first one in the book, which includes ends and angles, and I'm trying to solve for Ni, Nt, and theta t, and it doesn't want to do it. So that's a problem because I need that information to find further things. So for example, our value of Ts is reliant on getting that angle, and TP, same thing. And then to get power, we need powers relative to our power is power transmitted by that equation, which was in our text, and then same thing with P. And again, we already have our in. Now we just need to find our transmitted. And I've already got um, um, let me just pause. Okay, I guess I was confused there for a second. Now I'm good. So now to find intensity, intensity is relative to power and area. So I got 2 equations here I'm solving for, and that is area T equals so the transmitted area, I should say, is the I incident AI over ITS times that times TS, which is that squared, which we could probably simplify some things, I'm sure, but I'm going to let Mathematica be complicated. Like I know that'll cancel. Anyway, okay, and then we have ITS equals PTS over AT. So that's just saying intensity is power over area, and we're looking for I and A. Because we have to find that. Okay, but reflection is a lot easier because there is no area change. So the equation is simply the intensity equals power, since the reflected area and then the transmitted area is the same. It only changes in the process of refraction. Okay, so now we got intensities, we've got powers, we've got areas, we've got indices of refraction, and finally we know that our electric field, our reflected and transmitted S and P fields is just the square root of our intensities, but we need to calculate that. So So I guess where I'm stuck is this. So any feedback there would be excellent. And hopefully this was a little bit better than my initial submission.